The air rotary and down-the-hole hammer drilling systems are similar in design and function, with the main difference being the latter system having the additional cutting action of the air-driven hammer. First, we will profile the air rotary system, followed next by the down-the-hole hammer. The air rotary drilling system is primarily designed for drilling in consolidated formations, offering good penetration rates and quick cuttings removal. This system usually consists of a truck-mounted drill and separate support vehicle which carries supplies required for the drilling process, such as water and welding equipment. If the horsepower requirements for the truck are similar to the horsepower requirements of the drill, one engine can be used for both by utilizing a transfer case. This rig's equipment includes an air compressor and both water and mud pumps to help facilitate the removal of cuttings, depending on the geology encountered. Please note, for demonstration purposes, no surface casing is being used to better illustrate these processes. Air rotary drilling systems can utilize a number of cutting actions: rotary crush, rotary cut, or rotary percussion, shown here as rotary crush action. The flushing media used is dictated by the geology, and options include air alone, air and water combined, or with the addition of drilling foam and polymers to further enhance cutting removal. First, air alone. Please note the quality of the cuttings. They are very clean, representative samples of the formation. Water is added to enhance the air's ability to remove the cuttings. Utilizing the supply truck's reserves and a direct circulation system, water is pumped by the injection pump from the truck down the hole through the drill string and up the annular space between the string and the borehole, removing cuttings out of the hole and onto the adjacent ground. Notice how the quality of the cuttings has changed. The addition of water has masked the cuttings, making it more difficult to identify the formations and record them accurately. Drilling foam can be added to the water, which helps fill voids and suspend the cuttings in the annular space. Operators must mix carefully to ensure foaming action occurs down the borehole as opposed to in the mixing tank. Manufacturers' guidelines and recommendations must be followed closely to ensure optimum performance and safety when using these products. The foam fills the annular space, further enhancing the removal of the cuttings. Once the foam has dissipated, you can clearly see the cuttings again. The drill string sections are threaded together to enable drilling advancement.
I'm not on the bottom, on the side.
Penetration rates are dictated by the geology. For consolidated material, slow penetration rates require slow rotation speeds and lower volumes of flushing media. As the material becomes less consolidated, the rotation speeds and penetration rates increase, as do the demands on the flushing media. The drill string is then tripped out of the borehole to facilitate casing installation.
Remember, don't watch it go down. Slide her down.
By utilizing a rib stabilizer on the drill string, the resulting borehole is smooth, straight, and true, best facilitating the grouting operations to follow. The steps involved with the casing installation may include initially welding a casing shoe on the first section of pipe. This shoe protects the end of the casing during hole construction and enables the casing to be properly seated with the rock. The shoe must be welded to provide a watertight seal around the pipe. Care should be taken to collect spent welding rod ends. Additional sections of casing may require centralizers to be welded onto the casing to assist with uniform grout placement as per Regulation 903. A casing elevator is affixed to one end of the casing and is hoisted into the air and into position safely and securely. Two technicians are required to safely install the casing, as one person operates the hoist while the other assists by using a rope sling. Additional sections are welded or threaded together as the casing installation occurs. Grouting occurs to fill the annular space between the borehole and casing, as per best management practices and Regulation 903.